In this video, we're going to talk about graphing linear inequalities. So these are inequalities that have two variables, an x and a y, and we're going to graph using slope-intercept form, y equals mx plus b. So a quick reminder that m is our slope, the coefficient of x, that m is our slope, and what is added or subtracted, our constant, is our y-intercept. When we graph an equation, we graph that line, and wherever that line is on a graph is all the solutions that there are for that given equation. But when we have an inequality, we have to think about what symbol we have, and there are more solutions. So the first thing we need to look at is our inequality symbol to decide if we're going to have a dashed or dotted line or a solid line. So it is a dashed line, kind of like an open circle, if I have less than or greater than symbols. And I'm going to use a regular solid line if I have less than or equals or greater than or equal to. And this should make sense because when you graph a line like regular, if it's an equals, you're going to do a regular solid line. But if you are not including that boundary because it's just less than or just greater than, we use a dashed line. And that just means when I graph it, I'm going to use something like this. Solid is just going to be your regular line. The next thing that we do is decide which side we're going to shade on. Just like we have to shade on a number line, we have to shade in our coordinate plane. And so we need to pick a point to test, and that's what we're going to put here. Pick a point, not on the line, so it can't be on the boundary, and plug that into the given inequality. So we want to use an easy point like 0, 0 whenever possible. The only time it's not possible is if that's on the line that you've graphed. So if it's true, you're going to shade the side that contains the point. And if it's false, you're going to shade the opposite side from that point. Let's take a look at our first example here. Y is greater than or equal to 2x minus 1. The first thing I like to do is look at my symbol and make a note to myself that I want to graph a solid or a dotted line. So because I have that line, it's greater than or equal to, I'm going to have a solid line. I'm just going to make a note of that. Now I'm looking at my starting point. So right here, this is my y-intercept. So I go to my y-axis and I'm finding -1, which is right here. So that is my starting point. Then I'm going to look at my slope. I have 2, and remember when I have a slope that is an integer, I can put that over 1. So from my starting point, I am going to go up 2 to the right 1, up 2 to the right 1, and plot some points here, and then use a straight edge to connect those. Now that I have my solid line graphed, I need to decide whether I need to shade on this side of my line, like are all of these solutions, or do I need to shade on this side so that these are my solutions? So I need to test a point, and I always like to test 0, 0 as long as it's not on my line, and it's not. 0, 0 is this point right here, and I'll show you what I mean by testing it. When I test 0, 0, that means I go back to my original equation, and for y and for x, I plug in 0. So that means in this inequality, I have 0 is greater than or equal to 2 times 0 minus 1. And so I'm simplifying the right side right here. So 2 times 0 is 0. And 0 minus 1 is -1. So I'm asking, is 0 greater than or equal to -1? And if I look on this number line right here, I can see that 0 is to the right of -1. So that tells me that this is true. 0 is greater. So this right here is yes. That came out to be true or yes, and I want to shade that side. So you're shading everything on this side of the line. And what this tells me about this graph is that any point that's along this line would make this inequality true, and any point that's over here. So if I pick this point of negative 10, 10, and I plug that in for my x and y, I would get a true statement. Any point that is on this half of our graph extending forever would make this inequality true. Let's take a look at another one. Taking a look at this, I have y is less than negative x plus 4. So the first thing I'm going to do is look at my inequality sign here. And I see that I have a less than, which means that it's going to be a dotted line from this up here. It's just a less than, so it's going to be dashed. And I just like to write myself a note, so I try not to remember that or forget that. So this is going to be dotted. And now I'm going to start graphing. So the first thing when I'm graphing is I'm looking for the y-intercept, my b value. So this tells me that I'm going to plot a point at 0, 4. That's on my y-axis. That's right here. And then I'm going to take a look at my slope. I see that I have a negative. That can be thought of as a negative 1. So my m of negative 1, we can think of that as negative 1 over 1. I am going to go down 1 to the right 1, down 1 to the right 1, and plot those points. And I'm going to put a few here to get my straight edge lined up, and then I'm going to use a straight edge to plot that line. Remember to do dashed. Now that I have my line plotted, I can test a point, and again, I'm going to test 0, 0 because it is not on my line. Here's where 0, 0 is right here. This is the point that I'm going to test. And all test means is I'm going to plug that x and y in to my original equation. So y is 0, so I'll have 0 is less than negative 0 plus 4. I'm just plugging that in. Negative 0 is just 0, plus 4 is 4. So I'm asking, is 0 less than 4? And again, if I look at my number line, I look at 0 is here, 4 is here. If I just think of this as a number line, 0 is to the left of 4, so it is less than, which means this is a true inequality. It's a true statement. And so that means right here at 0, 0, that is one of our solutions. That's a yes. And so I will shade everything that's on this side. So remember, if it's a yes, you want to shade everything that is on that side. If it had come out to be a no, I would shade the opposite side. Let's take a look at our last example here. Y is less than or equal to 2/3 x. So I'm looking at my inequality sign. I see that it is with an equal sign. So I'm going to make that a solid line. I'm just going to write a note to myself to remember that this is a solid line. And then I want to find my y-intercept. I don't have a constant here. Nothing is being added. So that's like I'm adding 0, which means my starting point is going to be 0, 0. And then I'm going to take a look at my coefficient of x. That is 2/3. That's my slope. That means from 0, 0, I'm going to go up 2 and to the right 3, up 2 to the right 3, up 2 to the right 3, and plot some points. And you know you can go in the other direction to get some more points to help line up your straight edge. Take a straight edge and plot or draw that solid line right now. So I have my solid line graphed, but I can't test. It's time to test again to decide if I'm shading here or here. And my test point that I like to use 0, 0 is on my line, so I cannot use that. So I have to pick another one. I usually like to pick something where the x and y is the same number because that just makes it easier to make sure that I don't plug things in to the wrong spot. So on this one, I'm going to look at the point 3, 3. 3, 3 is right here. And the reason I want to test that point is because I have a fraction with the 3 in it, a denominator of 3, and that's going to make it a little bit easier. So I'm going to test 3, 3. So that means 3, we're wondering, is that less than or equal to 2/3 times 3. We don't have to put the plus 0 because we know that won't change. We can just plug it into our original. So 3 is less than, now 2/3 times 3 comes out to be 2. And you can do that in your calculator or see that your 3's cancel and you're left with just that 2 up there. So this is a question of, is 3 less than 2? And that is not true. That is false. So that means this side is a no, because 3 is not less than 2, which means I'm going to shade on my other side. So I'm shading everything on this side. And this is where all my solutions to that inequality would be.